Hello and welcome to GCSE exam questions on the topic of forces. So it's quite a big topic, as you probably know. There's lots of different questions in this, and these questions have all been taken from different exam papers in different years. Okay, so it's suitable for any GCSE forces questions. Okay, so also you might not start at number 1 because I've taken them from different papers. So which of these is the correct equation that relates force, mass, and acceleration? So you often know it as F equals ma. So I'm just put my pen on here. My ball pen. So you might know it as F equals ma like this. So what that means is F equals m times a. So it's that one. Okay. A cyclist has a mass of 70 kilograms. Calculate the force needed to accelerate the cyclist at 2 meters a second squared. State the unit. So we're actually going to straight away use F equals ma. Okay, so the force is F for force, m is mass, so 70 kilograms. That's already in the units that we want. And we've got acceleration 2 meters per second squared. So F equals 70 times 2. 140, and it's newtons, capital N. 140 newtons. Okay. Another cyclist travels 1,200 meters in a time of 80 seconds. Calculate the average speed of the cyclist. Use the equation average speed is distance over time. You probably know this from maths as well, don't you? Okay, average speed. So we're going to just substitute numbers in again. Distance, 1,200 is in meters, what we want. Time is in 80, so we don't have to convert anything here. We might later on for other questions. So 1,200, we can use calculators here, divided by 80. It's 15, an exact answer. That's nice. 15. Figure 3 shows a Mars exploration rover. The mass of the rover is 190 kilograms. The gravitational field strength on Earth is 10 newtons per kilogram. Calculate the weight of the rover on Earth. Use the equation weight is mass times gravitational field strength. This is one of the easiest questions here, isn't it? So weight is just 190 times by 10. Okay, 19, we just said a 0, don't we? So 1900 newtons. So weight is a force. Okay. The weight of the rover on Mars is 700 newtons. Calculate the gravitational field strength on Mars. Okay, so let's think about the equation here. We've got weight is mass times gravitational field strength. Okay, sometimes we shorten that to W equals mg. Let's do that. M times g. So weight. So we're told the weight 700 newtons. Its mass is the same everywhere in the universe. Times g. So we don't know g, and that's what we're trying to work out. So we're going to divide both sides by 190. So 700 divided by 190 is equal to g. So we can do our calculators. 700 divided by 90. Yeah, 7.7 reoccurring. So we're going to shorten that to, so what we'll do is we'll shorten that to 7.8. 7.8 newtons per kilogram. This Mars is actually smaller than the Earth, so it has actually a lower gravitational field strength. Which of these is a vector? So a vector, remember, has a magnitude, so a size, and a direction. Energy, does it make sense to say 20 newtons east or something like that? Sorry, no, sorry, not 20 joules, sorry. 20 joules east, no, doesn't really make sense. Force, yes, that is a vector. So forces, you use arrows, don't you? Well, actually, let's just talk about the other ones. Mass, so I just said that, yeah, mass in kilograms, and it's the same everywhere in the universe, okay? And yeah, so it doesn't have, and work, so work is actually joules, actually energy as well, so no. It is force, because force is measured by an arrow. Think about it. If you had a force on a box, on a table, you'd draw like an arrow, wouldn't you? Force. State the equation that relates acceleration to change in velocity and time taken. Okay, so you don't even have to remember this because there is, think about what acceleration is, you can work it out. So acceleration, okay, is changing velocity over time. We're actually kind of giving you away. So this is writing words first of all. Okay, over time taken. Well, that will give you a mark. We're going to be even more precise and do a bit of an extra thing. Change your velocity. So V minus U, you might see it as, over T. So V is the final speed or the end speed. And U is the starting or initial speed. Okay. A fan accelerates from a velocity of 2 meters per second to a velocity of 20 meters per second in 12 seconds. Calculate acceleration. This is a good say. Yeah, that's why we did this, because I could see there was a question coming up. Like V, final speed, 20. Minus starting speed. So it's not always 0. That's why I said the starting speed over 12 seconds. Right, so we've got 20 minus 2, 18 divided by 12. And again, we can use a calculator. 18 divided by 12, 1.5. So 1.5 is acceleration, so it's meters per second squared. And if you want to underline that, it's a good idea actually in these sorts of questions to show you finished. So someone marking it will look through it and will look for the underlining like that. It makes it a bit easier for them. More likely for you to get marks for it. Figure 17 is a velocity time graph for 15 seconds of a cyclist's journey. Got a lot of people riding bikes on this paper. So time in seconds, velocity. So calculate the distance the cyclist travels in 15 seconds. Okay, so there's a reason why this is not a very reasonable graph. There is a reasonable graph, like it's a straight line like this. Okay, you kind of know what's going to be. So let's think about the equation. So let's think about velocity or the speed. So velocity. Okay, so this distance divided by time, isn't it? So let's just go back to that for a minute. We want to find distance. You might think, what's this got to do with the graph? Do not worry, this way it's coming, right? So if you find distance on its own, you do velocity times time equal to distance. It's just rearranging the equation. That's all I've done. I haven't done anything else yet, just rearranging the equation. Okay, so we've got velocity up here, and we've got time down here. So actually, what it's going to be, it's going to be the area under here, area under the triangle. Okay, so we've got velocity. So calculate the distance. So velocity, so up to here, we've got 7 times 15. It's a triangle. So if we did 7 times 15, we'd get a square. So we need to divide that by 2. Okay, so 7 times 15 divided by 2. 52.5 meters. Okay. Area over area, I can say area underline, area of triangle. same thing. There's a triangle, so you've got to do it divided by 2. Many factors can affect the stopping distance of a car. Some of these factors involve the driver, and some of these factors involve the car or the road. Explain how the stopping distance of a car is affected by factors involving the driver and factors involving the car or a road. You should include examples in your explanations. Actually, it's a really good opportunity, isn't it? Because this is a kind of common sense thing. A lot of people know this. Okay, so the driver, factors of the driver. So there's lots of things here. So the person. So you could have things like how awake the person is, so it affects reaction times. Slower reactions when tired. So drugs or alcohol. Some drugs, so it could be like medication as well, I'm trying to say, not to say illegal. So some drugs and all alcohol increases reaction times. So both of these, okay, what this means together is the longer the reaction time, the longer the stopping distance. Right, okay, there's a few, okay, so we don't need that then. We'll go to the car because there's lots of things here. Right, how effective the brakes are. So the person could actually put their foot on the brakes, but if the brakes don't work, brakes are, so there's a thing called brake pads which rub against the wheel. So worn out brakes, literally worn out brakes, brake pads would increase stopping distance. Oh, the tyres as well. Think about one as well. We'll have 2 for each. So tyres that are in bad condition. That's why you have to get your tyres checked. It's actually illegal to drive what's called a bald tyre. A bald tyre is when that tread has worn down, okay, can increase stopping distance. So roads, we all know these. So wet or icy. Surfaces will cause car to slide and increase stopping distance. Okay. A diver is swimming underwater in a lake. The diver wears the meter shown in figure 3. The meter shows the depth of the diver below the surface of the water. State the depth shown in figure 3. State the unit. Right, so let's have a look at the depth. So 6 and 8, so 6. So 7 is the middle, so it must be 6.5. It's meters, isn't it? State how the pressure of the water on the diver changes as the diver swims down from the surface of the lake. So the deeper the diver swims or dives, the greater the pressure on the diver. So state why the total pressure on the diver is greater than the pressure due to the water above the diver. So lots of people get this wrong. So there is also an atmospheric pressure. So pushing down. Okay. An aeroplane takes off from the ground. State 2 factors that affect the pressure of the atmosphere on the aeroplane as the aeroplane goes higher in the atmosphere. Okay, so the higher plane flies, the less atmosphere above the plane, and the lower the pressure. Next one, so the higher you fly as well, the higher the plane flies, the lower the temperature. So the lower the pressure again. Okay. Figure 8 shows the force of 70 newtons turning a lever at about point P. Calculate the moment of the 70 Newton force about point P. State the unit. Use the equation. Moment is force times distance normal to the direction of the force. Okay, normal means at right angle. So we've got moment. Again, we're just substituting values. Force 70 newtons. Distance, right, 0.4, we have to in meters. So 70 times 0.4 we're doing here. 28. 28, oh, let's look at Newton meters. Okay, so we're timesing newtons by meters here, okay? So I'm going to stop the video there, okay, for today. So thank you for listening and hope to see you in another video and good luck on your exams. Thank you, goodbye.